Good morning, all students. Today we meet again in online learning SMPK Manabu. I hope all of us still in a good condition. After at the previous meeting, we have already learned about ionic bonding and covalent bonding. Now we will learn the new part about molecules. Molecules. In our world, we find atom rarely stable or in independent state. Most atoms join together to form a molecule. What is molecule? A molecule is composed by two or more atoms. Its constituent atoms are chemically bonded together called covalent bond. While we talk about molecule, there is molecular formula. So what is molecular formula? Molecular formula is a chemical formula that gives total numbers of atoms of each element in a molecule. Molecules can be classified into two groups based on atoms bonded together. The molecules can be composed by the same type of elements or different types of elements. The first group is molecules of element. A molecule of element is composed by two or more than two similar types of atoms. Examples of molecules of elements are O2, Cl2, B4, and S8. While we talk about molecule of element, we talk about atomicity. What is atomicity? Atomicity is the number of atoms bonded in a molecule of element. Molecule of element can be classified based on atomicity as diatomic molecules, triatomic molecules, tetraatomic molecules, and polyatomic molecules. Diatomic molecules. What is diatomic molecules? Diatomic molecules are made up of two atoms. The two atoms share an electron to create stability of electron configuration. This process we have learned at the previous meeting and is called as covalent bonding. With this bonding, so the stability of atoms can be achieved and obey duplet rules or octet rules. The example of diatomic molecules are H2, O2, F2, and etc. Now we can see the first figure. Here is the figure of hydrogen molecules H2. As we can see, there are two atoms sharing at the first shell of hydrogen atoms. The sharing of electrons obey duplet rules. With the sharing electron, hydrogen atoms can achieve stability of electron configuration. And from the second figure, oxygen molecules O2, we can see that there are 4 electron sharing in here at the second shell. So with the sharing of 4 electrons, the atom oxygen can achieve stability and obey octet rules at the second shell. And the third figure is the formation of fluorine molecules F2. And we can see from the figure there are 2 electrons sharing at the second shell. So with the sharing of 2 electrons, fluorine atoms can achieve stability of electron and obey octet rules at the second shell. Triatomic molecules. Three atomic molecules are made up of three atoms. The three atoms sharing electron to create stability of electron configuration. As we know that the three atoms sharing electron is called as covalent bonding, that at this bonding using octet tables. Example of three atomic molecules is ozone molecules, O3. Here we can see the formation of ozone molecule O3. At the left side, that shown by blue arrow, there are four electron sharing to obey octet rule. And at the right side, shown by red arrow, there are two electron sharing to obey octet rule. Now, tetraatomic molecules. Tetraatomic molecules are made up of four atoms. The example of tetraatomic molecules is E4. Last, polyatomic molecules. Polyatomic molecules are made up of many atoms. Example of polyatomic molecules are S8, B12, C60, and etc. Second group is molecules of compound. A molecule of compound is composed of two or more atoms of different elements in definite proportion and chemically bonded. Examples of molecules of compound are hydrogen chloride, carbon dioxide, ammonia, and etc. This is the figure for formation of hydrogen chloride molecules. As we can see from the figure, as shown by red arrow, there are two electron sharing. The two electron sharing for hydrogens is to obey duplet rules, and for the chloride, the sharing electron at the third shell to obey octet rule. So the stability can be achieved. From the second figure, the formation of ammonia molecule. In here we can see that there is sharing electron between nitrogen and hydrogen. Nitrogen and hydrogen sharing two electrons. So hydrogen can obey duplet rules. And because nitrogen sharing electron with three hydrogen atoms, so there are six electrons sharing with nitrogen at the second shell. So the nitrogen sharing electron to obey octet rules to achieve stability of atom configuration. And the last figure is carbon dioxide, as we can see, that's shown by red arrows. At the left side, there are four electrons sharing between atom O and atom C at the second shell. And at the right figure, there are four electrons too, sharing between atom C and atom O. So in here, with sharing electron, atom carbon obey octet rules, and two atom oxygen obey octet rules too. So in here, atom C and atom O can create or can achieve stability of electron configuration. I think that's all our materials today about molecules and the group of molecules, element molecules and compound molecules. I hope these materials can enhance your information about molecules. God bless you.